look at the practice exam. Okay, so again, quite a few of these problems are actually going to appear on the exam, so this is a very, very effective study guide. It's done right. All right, so we talked about a lot of different things, talking about Jupiter and Saturn in the outer solar system. Jupiter is known to emit about twice as much energy per unit time as it receives from the sun. Does anybody remember what the explanation for that is? It would be B. No, I'm sorry, not B. It's not on, well, this is a two-parter, right? Sorry. It's Jupiter, and then we asked the same question about Saturn. So yeah, B. Because in the case of Jupiter, it's no, wait a second. Get myself confused here. It's A. Because in the case of Jupiter, it's escaping residual heat, and in the case of Saturn, it's this ongoing differentiation, which we also call the helium rain. Helium rain. That was actually, does anybody remember the Prince album? Helium rain? Good. Could have said the artist formerly known as Prince. No more need to know what I was talking about. You know, I can talk about it again. Okay, most common gas in the atmospheres of Mars and Venus is what? CO2, good old CO2 that we can't breathe. Most common gas in the atmospheres of Jupiter and Saturn, I'm into it. H2. Yes, H2. Okay. Okay, so we see evidence for water flow on Mars. Let's see, the channels and outflow features discovered on Mars show that there was a huge flood of water from the south to the north, so that we can see. We also talked about asteroids. We talked about the Apollo asteroids. They're actually the asteroids that cross Earth's orbit, and the Trojan asteroids cross Mars' orbit. No, sorry, the Trojan asteroids are the ones that are 60 degrees in front of and behind Jupiter. So this would actually be B. Apollo asteroids cross the orbit of Earth, and the Trojan asteroids are in these Lagrange points, 60 degrees in front of and behind Jupiter. Okay, this is an interesting one. Impact craters on Mercury, we've seen are smaller than craters on the Moon, which is weird because Mercury has a higher gravitational attraction. So you'd think that craters would be larger on Mercury because of the more violent impacts. But it actually turns out that they're smaller on Mercury compared to the Moon because the higher surface gravity of Mercury actually causes the ejecta to not fly out as far, and that effect wins out over the stronger impact. So it actually would be C. Magnetic fields. Okay, so this covers a whole lot of different things at the same time. Earth, Jupiter, and Neptune, we're going to have iron, metallic iron, we're going to have metallic hydrogen, and then ionic slush. So that would be B. But we just talked about how Uranus has this 98-degree tilt and Venus has this retrograde spin. Again, they break the general pattern of regularity that we see in the solar system, so we believe that those are probably due to violent collisions in the distant past. Clouds on Venus are composed of what?
Carbon dioxide.
Sulfuric acid, yes. And we think the water is gone because it's been destroyed by solar radiation. So this would be B. That's the runaway greenhouse effect. It's a runaway greenhouse effect because the water has been chemically removed from the planet, not just frozen into the surface like we see on Mars. Okay, Val Marineris on Mars was formed by what versus the Grand Canyon? It was formed by E, exactly. Tectonic fracturing, whereas the Grand Canyon was water erosion. Okay, reverse runaway greenhouse effect. So it's the reverse runaway greenhouse effect on Mars because instead of overheating, it's overcooling. That's what we mean by reverse. And then it's runaway because the cooling led to more cooling and the loss of greenhouse gases. So basically the short answer to this question would be that D, the planet was too cold for enough carbon dioxide and H2O gas to reach the atmosphere to form a thermal blanket. So instead, that stuff precipitated out, leading to more cooling, which led to more precipitation. So that's that runaway type of cycle. Okay, Venus is very hot and Mars is very cold. The coldness of Mars could be reversed in the future because we can heat up and melt the ices that are underground. But we can't change Venus because the water molecules have actually been destroyed. So this would be C. The water has been split up by solar radiation with the hydrogen escaping into space. Again, that's the chemical change on Venus, but on Mars, not a chemical change, just freezing. So we could theoretically heat up Mars and actually reconstitute its atmosphere. The blueness of Uranus and Neptune are because of the presence of methane, B. Theory of the moon's formations. This is another thing we covered during this section of the course. What would the answer to this one be? Yes. Right. Because the other ones seem to be ruled out at various things we talked about. So we think a collision with a Mars-sized body actually led to destruction of the moon. Okay, so here rotation period, Jupiter's magnetic field. 10 hours. Big planet that rotates much faster than the Earth does, hence why we have these strong magnetic fields. Okay, clouds observed on Jupiter and Saturn have rotation periods at various latitudes. What kind of rotation is that? Differential. So it's differential, so that narrows it down to B or C. The motion of the great red spot on Jupiter is driven by pure motion, so it would be B, the correct answer here. The internal heat that powers volcanoes on Io. Remember, this is interesting because at Io's distance from Jupiter, you'd expect Io to be in a synchronous orbit, tightly locked orbit like our moon is, but it's not because of, well, it's not because of the influence of Europa. But anyway, the point of this question is that the internal heating that powers volcanoes on Io is actually due to tidal forces from Jupiter, which are occurring because Io is not in a tightly locked orbit, and that's because of the influence of Europa. So it's kind of a chain of things there that lead us to the point where Io is currently still being heated by the tidal force of Jupiter, surprisingly. All right, so this is a theme I've hit on over and over again in the last few weeks. The density of the planets decrease as we move outward from the solar system due to potentially differentiation, which causes the dense material to stay near the sun. So it would be D. Decreases, and then it's due to differentiation. Dust tail of a comet. Okay, actually, we didn't get to this. This isn't going to be on this particular exam. We didn't cover the comet chapter. We'll get to that after the next exam. All right, so dating on the moon. Again, based on telescopic observations, we see that there's far fewer craters on the Maria than there are on the highlands. And so this led scientists to believe that the highlands were about 4 billion years old and the Maria were 100 million years old, so it would be C. Now remember, this turns out not to be true. That conclusion is based on the assumption that the cratering rate is constant over time. So then, if that's true, when you look at the Maria with so fewer craters, and you assume they must be very young compared to the highlands. But the actual explanation is that the cratering rate changed around 3 billion years ago. This is exactly what the next problem is getting into there. When we did radioactive dating of the lunar samples, we found that the difference in the highlands and the Maria age is only about 500 million years. So the fact that the Maria has so fewer craters actually means that the cratering rate dropped in the solar system around 3.5 billion years ago, so the correct answer would be B. All right, we talked last time about helium precipitation on Saturn. It occurs on Saturn but not on Jupiter because Jupiter is a little too warm for helium to condense. So that would narrow it down to either C or D, right? And then the hypothesis of helium precipitation helps to explain its higher temperature. It's not really a high temperature, it's just a little higher than expected. And also the lack of helium, not methane, but helium. So the correct answer would be C. The gaps in Saturn's rings, we just talked about this today, are caused by orbital resonances with Saturn's moons. The Kirkwood gaps in the asteroid belt we have not discussed yet. There's more of that. That's going to come the chapters that we're going to discuss after the exam. but it does turn out to be a phenomenon that's similar to the gaps in Saturn's rings. All right, another question about synchronous orbits here. Mercury is very close to the Sun. We would expect a synchronous orbit, but it's not actually synchronous because of what? Right, because the orbit's actually elliptical, and elliptical orbits can't be perfectly synchronous because of the change in speed as the planet gets closer and farther from the Sun. All right, the density of Mercury, similar to the density of Earth, so that, remember, the density always tells us something about the structure and composition. So what is this telling us? C, probably massive iron core, right? All right, the average densities of the Moon and Mars are similar, 3 to 4 grams per cubic centimeter, so that narrows it down to C or D. And so we conclude that both objects do not have a large fraction of iron, right? So it would be D. The densities of the Jovian moons decrease with decreasing distance from Jupiter, but the moons of Saturn do not show this trend. This is interesting. Well, the implication of that is that Jupiter radiated a lot more heat during its formation than Saturn did. So we see more differentiation in the moon system of Jupiter than we see in the moon system of Saturn. In other words, all of Saturn moons are pretty much icy, but the inner moons of Jupiter are quite rocky because close to Jupiter it was hotter than it was close to Saturn. And so Saturn, being cooler, was able to have icy moons, but the inner moons of Jupiter are very rocky, so we see this change in density as we move out amongst the moons of Jupiter, but not so for Saturn. 70% albedo of Venus is due to, in case you can't hear, I'm throwing my fingers, it's due to B, the reflective cloud layer high altitude, right? Spin axis of the planet Uranus is tilted 98 degrees. This is going to cause extreme seasonal variations, so that's B. The Cassini division of Saturn's rings is due to what? We just went over this. I'm sure you're going to nail this. Exactly, D. 2-to-1 orbital resonance with Mimas. And then the planet Mars is easier to observe during a favorable opposition because what? E. Actually, a bunch of different things. A favorable opposition, remember, opposition means that Mars is in the opposite direction from the Sun. So you're going to see the full phase of Mars, which is the C there. But because a favorable opposition means that Mars is at perihelion, which is minimum distance from the Sun, so it's also going to be B. It's also going to be the minimum distance from Earth, so it's A, B, and C, which is covered by E, so E is the best answer there. Okay, so it'd be a good idea to study your bodily parts off for this third exam, because if you can maintain a good average going to the third exam, I'll give you your grade after 3 exams, and then you may not need to take the final. So a lot of incentive to do well in this third exam if you could really simplify your life going into finals in December. All right, if you have any other questions, you can email me or try to make plans to get together for further review. Yes? Yes, the finals good. Yes, you can see it. Yeah, need to make an appointment to do that, but I probably